Negative side, positive side. So we're going to try and figure out what to do here. I'm going to strip this off. Lop this end off. Right, the bucket bucket. Pull out the shielding. Some insulation. Let's trim this insulation back a little bit farther. Alright, so we got the shielding peeled back, and we've got some of the wires exposed here. Yeah, what's up? No, I don't know where your glasses are. So the shielding's exposed. Now we need to find out which wires here are the positive and negative, and which ones are the signal wires. Probably these two are going to be our positive and negative, and these are probably going to be signal. So eventually we figure that out. If the signal wires, we'll just lop those off. Wires exposed. Let's get some solder. Some test leads. Let's plug this into the wall and see what happens. Okay, these are live. Now we're looking for a signal, and then plus 5 volts and neutral. Put in DC mode. I'll test this out. connector to make it a little bit easier on ourselves. I only have to test one at a time. There is no standard necessarily for how these are wired up, and shit mostly comes from China, so all over the place. Alright, that's nothing. Nothing. Make sure this is reading 0. It is. Alright, let's peel back some more. Disconnect the power. Connect power. Look at that. Plus 5 volts. There you go. 5.14, 5.15 volts. Alright, cool. So now the other two we know are useless. Let's go ahead and disconnect power. And let's lop these guys off because we don't need these. Yoink. Those are just signal wires. They're not voltage carrying, so not really useful. Alright. Done. Okay, so now we got our signal, or pardon me, our plus 5 volts and ground. Ground's looking a little janky. Let's go ahead and clean that out. That's better. This is such thin wire, it's gonna be pretty easy to destroy it, even with the side cutters. It's just so thin. Now it's on our soldering iron. Let's do a little test. Okay, so we got our plus 5 volts, negative, and our ground. Hook this up. We're going to hook this up to positive terminal here. And we're going to hook this up to the negative. We'll see if this thing turns on. Or if it lets out the smoke, goes up the ghost. And we're connecting it to USB power supply. 5 volts. And there we go. It's chooching away. We got some Canadian joy. Alright, so let's make sure that power switch still works. Does, breaks contact. Cool. Let's just check what the current draw is here. I'll check the voltage, see how much we're getting dropped across these terminals. So we're getting 3.6 volts. Wow. See, it's drawing a lot of current. Yeah, this power supply here is not probably designed for that kind of current draw. That's why we're seeing a huge sag. Yeah, this thing's getting a little burny smelling. It's only rated for 850 milliamps. I don't know if you can see that. 850 milliamps right there. Yeah, there you go, 850 milliamps. So, pretty small power supply. Not really rated to do this kind of job. Let's plug it in again and just kind of see what sort of power this thing is drawing here. See how much current it's drawing. we're going to hook the multimeter up in line. Get one more alligator clip. Hook this up to the negative line here, negative terminal. Connect this put this in current mode. We'll start with 10 amps. 10 amp section. Reconfigure 10 amps, put it in DC mode from AC, and connect that up. Okay. Connect this here. I take the negative terminal and connect this to the negative coming off the power supply. Alright. We're going to connect this up to our load. Okay. I'm going to switch on the lights. This is only drawing, I don't know if you can see that, 0.25 amps, but it is not turning on. Yeah. So that's kind of weird. So that tells me the voltage is too low. Yeah, that little power supply probably can't supply enough current to keep this thing running. Let's take this out. Yeah, let's get a stronger 1 amp power supply here, like a Google, one for that Google Home. Sorry, I wish I had a bench power supply, but well. Here we go. This is a Sam Suckett power supply rated for 1.2 amps. Okay, I don't know if you can see that. 1.2 amps. So a little bit beefier, not that much, but a little bit more. Give this a shot. Let's check the voltage here. It's back to COM. Four volts, that's sagging pretty badly. So let's go ahead and switch those off, and let's pull out the let's pull out the non-contact amp meter here. For this. This just allows us to measure the current flow without actually putting something in the loop. I'll put this on negative, and we'll switch on our load. Zero it out first. Okay. Wow, 1 amp. Shit. I don't know if you can see that, but it's reading 1.3 amps. That is basically the limit of that little power supply. So pretty high current draw. Yeah, very high current draw. That's why it's sagging so hard. Okay. So when your powering these, I would probably recommend a 2 amp, basically a 10 watt power supply for these. So when you're shopping around to get a USB charger, you're going to look at something here on the back. I'm looking for these numbers here where it says 5 volts, 1.2 amps. You're going to be looking for something that's 2 amps in order to supply enough current to safely power these Christmas lights here. Alright, so now that we know kind of what the current draw is, let's go ahead and solder these up. The reason we want to figure out the current draw is we want to be able to safely power these without causing a fire, because originally this wasn't designed to be powered off of a DC power supply, which is what we're converting it to do. So let's connect these. We just come right through probably this opening here. That'll work just fine. Peel back some of that shielding. I need more space there in order to actuate the switch, so come back to like here. Okay, so now we trim back the wires a little bit more so we can get some distance here. Let's get these up in the helping hands and get some solder on these things. About 730 degrees Fahrenheit. Plenty hot to melt this 6040 leaded tin solder. I wet these tips here. Alright, let's come over to this contraption. There's already some solder on this, but we're going to add a little bit more solder. Now there's solder here, but we don't want to disconnect that original connection, so a little bit of solder there, we're gonna just use that, what's existing, add to that. Be careful not to melt the plastic. A fresh bead of solder. We're going to do the same here. Alright, got some solder on both of those. Put that away, and you can actually smell the crustiness, the Chinesiness. It's delicious. Alright, let's go ahead and tack on the the negative lead. Okay, negative's tacked on. Let's go ahead and tack on that positive. Okay. Tacked on, make sure you got our polarities correct. Positive on the right, negative on the left. We'll find out in a hot second if we did it correctly. Okay. Go. And they're lighting up. So all seems to be well with the world. Let's go ahead and disconnect the power. Okay, fish this through. This switch here. Put on the case. And there you go. Converted to USB. Now the important thing is here is you need a pretty powerful 5-volt power supply. You know, just your regular garden variety phone charger is not going to do. You need something that does about 10 watts. These are actually super power hungry. Way more than I thought they would be. So just keep that in mind. All right, that's it.